Our next job here is to consider the graph of the cotangent function. So I have y equals cotangent of x. Now, without going into all the detail from before, we can use the stepping stones from the tangent discussion to get us across the creek for discussing about cotangent. Now, recall that cotangent can be represented as cosine over sine. And so just like tangent has a vertical asymptote anywhere its denominator, cosine, has an x-intercept, then cotangent has a vertical asymptote anywhere sine, its denominator, has an x-intercept. And recall that the graph of the sine curve, where are the x-intercepts? They are at 0, at pi, at 2 pi. The next would be at 3 pi, negative pi, negative 2 pi, at all the integer multiples of pi. When I say integers, I mean negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, and so on in both directions. And so these are the integer multiples of pi. So anywhere sine is equal to 0, that's where cotangent has a vertical asymptote. So vertical asymptotes for cotangent are at 0, at pi, 2 pi, so we have a vertical asymptote. Whenever I have an axis, I'll just kind of cross it like this so it's obvious what's going on here. Here's pi over 2, here's pi. 3 pi over 2, here's 2 pi. And if we wanted to have more, we could put as many as these as we like. Here's negative pi over 2 and negative pi. And we can extend this as far as we like in either direction. Now, it is not obvious, but we'll just take it for this for now. The graph of cotangent is not simply tangent shifted over to the side. The most common error students make is they just take these strips and then they put in the similar picture to tangent. That cannot be correct. And it has to do with the argument we made in the preceding video. This is the interval from 0 to pi over 2. This corresponds to quadrant 1 in the unit circle. The x values in this interval, 0 to pi over 2, correspond to the angles in quadrant 1. But in quadrant 1, all functions are positive. If we were to simply draw this strip as if it were the tangent curve shifted over, these values would be below the x-axis. That is not correct. And so it turns out this is the graph of the cotangent curve. You could plot as many points as you like, but this is the graph you would get. In the interest of time, we're going to just take this as fact. This is the graph of the cotangent function. And that continues as far as you care to make it in both directions. All right? So in that direction and in this one. So the graph of the cotangent curve, it's tangent shifted over to the right, but also you reflect it across the x-axis, because in quadrant number 1, everything must be positive. It must be above the axis. That is going to help you get this correct where others might not. All right? Now, let me get some space over here. Let's talk about the properties here. Domain. Well, the domain is all the real numbers except we need to throw out the vertical asymptotes. And the vertical asymptotes occur, as we said earlier, at the integer multiples of pi. So the domain is all the real numbers except we throw out k times pi, where k is allowed to be any integer, any one of the whole numbers or their negatives. If k is 0, then this is 0 times pi, which is 0. We've thrown out 0. There's a vertical asymptote there. When k is 1, this is 1 pi. We've thrown out that vertical asymptote value. When k is 2, it's 2 pi, and so on. When k is negative 1, there's negative pi we've thrown out that I've erased over here, but it's still a value to be discarded. So this is the expression that represents the domain of the cotangent curve. It's all the real numbers, but you discard the integer multiples of pi. It is not the same. It is not the same as sine, not the same as cosine, not the same as tangent. So those are different values. All right? The range, I think the range is obvious. We're using the entire y-axis. So the range is all the real numbers. The period is the distance required for the function to repeat itself, the minimum distance required for the function to repeat itself. That is obviously, in this case, pi, because in that distance it repeats itself, in that distance it repeats itself. So the period is pi. The period of cotangent and the period of tangent are the same. And then the basic interval, or standard interval, the standard interval is when you take, if you're going to graph just one period, one of these strips, the standard interval used is from 0 to pi. Again, you do not include the endpoints because these are asymptote values. Those values are not achieved. So there's the graph of the cotangent function. The vertical asymptotes occur where the denominator is equal to 0. There's the cotangent function, and then here are the basic facts about that cotangent function. Domain, range, period, and basic interval.